Hello, everyone, and welcome back. We are going to continue on with our discussion of the strings today. So last time we talked about some of the things we've seen about strings and just kind of had a reprise of all the different things we've done with strings now. And we also talked about some of the built-ins that Python has in order to work with strings. So today we're going to continue on talking about the built-in things that Python has to work with strings. Now, today's are going to be a little bit less obvious. These are going to be some operators that work on strings. I remember operators like the plus symbol, minus symbol, multiplication, division. These are the typical kinds of things we think about when we're talking about operators. But these operators are not really going to look like operators, but they actually are. They're going to be the square parentheses, and you can think, oh, it's just a little parentheses, but it's not. It is an operator, and they can do some really interesting things. So we're going to take a look at the string processing. We'll be looking at the indexing and the slicing of the strings. So then let us go ahead and take a look at some of this. So I'm going to share my screen as usual, and you are most welcome to follow along in the video or with your actual slide downloads as you see fit. So string indexing, and you can see that I've got these little brackets right over here. Don't they look cute? I mean, they just look so innocent there. It just looks like parentheses, but that's really the star of the show. All right, let's see if we can go to the next slide. Okay, so string indexing, the index operator, which by the way is both of those brackets together, and that's also a little bit strange because most of our operators are just one character. So we have seen operators that have two characters, like the not equals is the exclamation point equals, or less than or equal to, but they always come together, right? So they follow one right after the other. But the index operators don't have to do that, but they still operate just as one thing. So the operator looks up characters in a string. We're going to use these to go ahead and see if we can pull out a particular character in that string. The index operator is those square brackets. An index is used to specify which character or characters in the string to extract. So we might want to pull them out. So it's going to return back whichever characters you have selected. And then, of course, it's up to you to capture them in the variable and then do something else with them, or use composition to have that inside of something else. Indices may be positive, negative, or 0. We're going to specify a range to select more than one character, and a string can be considered by its characters, and they can be indexed in the forward, which is positive, or the backward, which is the negative orientation. So at this point, it's probably helpful for us to just take a little look at this string right here. So this is a string containing the word Michigan. Remember, of course, the quotes don't count for any positions in the string. We saw that when we used len, which ignores those for the counting of them. So I've just popped them on the beginning and end character, and then I have just divided it up so that we can count on it. We can count them easily. And so normally we'd start counting on the first position. Now, the thing about Python is that the counting begins at 0 in Python, and this can make things feel a little unusual, but this is how things are done in Python, and it does actually have a useful outcome of doing that. But it also means that we have this sort of a weird thing that in the forward direction and the backward direction, that the indices aren't the same. And let me explain to you what I mean by that. So here we can count up it using basically the counting numbers, except we started with 0, and then we can also index the characters in the backward direction, which is signified by the negatives. So we could do -1, -2, and so on. So this one runs from 0 up to 7, and so intuitively you might think that this one also should run like up to -7, but it's not, it's -8. And the reason is because of the 0. So why didn't it work? Well, because you would have to put the 0 here, but 0 has already been taken. So you can't use it again, because how would Python know whether you went forward or backward? So 0 is associated with the forward indexing, and the negatives are associated with the backward indexing. So this means that every character in here has more than one index. So for example, let's take this H right here. In the forward indexing, it's the 3rd position, but in the backward indexing, it's the -5 position. So then just working through our notes here, a string can be considered by its characters, and they can be indexed in the forward, which is this, or the backward, which is the negative orientation, which is this one. Indices greater than or equal to 0 begin at the left and tell the offset from that point, and indices less than 0 indicate the offset from the right end of the string. So it's just saying these work in the forward and backward direction. Forward indexing begins with 0 and runs up to length s minus 1. So if you were to say, what is the length of this? You would say the length of this is 8, but the indexing goes from 0 up to the length of the string minus 1. That actually turns out to be helpful, although that may not be readily apparent in the beginning. Okay, so let's just take a look here at the string indexing, some syntax and some examples. So I've just pasted this over here so that we can refer to our numbers on this particular string. So the syntax for pulling out our index would be the string and then the square brackets, and would put an index in there. So for example, I could do Michigan of 0, which will pull out the 0th element of the string Michigan, and that corresponds to M. Similarly, I can do 1 through 7 to pull out these characters. Notice that when it does pull it out, it puts the whole character into the quotes. Now I can also index it backwards, and so I've actually matched this up. So M is also the -8, and so on. We can see that we can then work our way from -8 down to the -1. So again, the forward indices run up to the length of the string -1, and then we go from -1 down to the negative the length of the string. And that has to do because we have that 0 that doesn't have a sign. So here's just a quick little exercise. What animal was used to haul barges along the Erie Canal? You may already know the answer to that, but go ahead and use these indexing to pull those characters out. You can feel free to pause the video if you'd like, and we will join you on the next slide to see if you've been able to do this. All right, so I hope that that was a fun little exercise for you. Of course, the animal that hauled the barges was the mule, but of more interest to us is really actually doing the indexing. So here are the various strings we had defined. So we have to go to S2 of the 0th position, which gives us M, and here we're going to the 4th string and taking the 1th element. So you might think, oh, it's H. But don't forget, the H is the 0th position. The 1th position is actually like the 2nd in counting numbers. So you get the U. Now we also have some examples of the negative indexing. So here we're doing S6 of -4, -1, 2, 3, 4, which gives us L. And S5 of -1 gives us this last E right here. We often give the name of strings as S as a convenient convention. We're just going to number them, but you can, of course, call your strings any valid Python string name that you like. Let's talk about those index bounds. Thus, we see that in order to be a valid index for a string S, a non-negative integer I, so the reason why we say non-negative instead of positive is because we also need to include 0, must run between 0 is less than equal to I and I is less than the string. So we saw that if we exceed that you've fallen off the edge of the string. So it goes to less than the length of the string, because the length of the string will be 1 too many because the indexing started at 0. And if you try to actually index something outside of that, so here's Erie, you might go 1, 2, 3, 4 and say, oh, S of 4, right, what's the problem here? But don't forget, you have to begin your indexing at 0, and that's why. A negative integer J must satisfy negative the length of the string is less than or equal to j, and j is less than 0, right? So 0 is not included in the negative indexing. That's what this is saying. The j is a negative number, or another way to say that is j is less than 0. It's negative. And the length of the string will be the integers, right? So if it's Huron 1, 2, 3, 4, 5, so that will be 5. So this will run from -1 to -5. And then if you try to go to -6, you have fallen off the edge and you will get an error. But why stop at pulling out a single character? What if you wanted to pull out multiple, or maybe you wanted to pull out a piece of the string? And so we can do that, and that is called the slice operator. It looks very similar to the indexing operator, although we recognize the slice operator because it has the colon inside, which is going to allow us to mention a start and stop index. This is called string slicing. The slice operator returns the substring of a string between two indices. So that means you're going to basically pull out a piece. It's like Scrabble tiles, and you pulled out some of them. The slice operator is, again, the square brackets with the colon on the inside. You use the colon to separate the start and stop indices. The slice begins inclusive of the lower index, but it goes up to but does not include the upper index, which may seem to be a little bit it's not really that congruous. You would kind of think it should include on both ends, but that's not how it works. It begins inclusive of the lower index and goes up to but not including the upper index. And so if you don't like that convention, you can complain to Mr. Guido van Rossum, who invented Python. So here's our string. And then we have our square brackets, and we have a start index, colon, and a stop index. So let's let our string be Michigan, and then we could say S of 0 up to, but not including 2. Now I'm going to use this little ray right here, and I'm going to harken back to some notation that you may have seen in your math. And that is that on the number line, did you ever indicate like which solutions are included in an inequality or something like that? You may have done the kind of thing where you fill in the dot to indicate that that number is included, and then you would show like an open dot, or I'm choosing the arrowhead to say it goes up to that, but it doesn't actually include that number. So I'm going to be drawing these little diagrams like this to help you see what's included and what's not included, so that you can easily see what's happening on the boundary condition. Now we have said that in the slice operator, it includes the lower one, so the lower part of the array will be filled in, and then the upper one is not included, so we'll see this arrowhead to say it goes up to there but doesn't include it. So here the idea is we want to pull out this slice from 0 up to but not including 2. So we have 0, 1, 2. So that will pull out M and I because it doesn't include 2. So we get MI. Here's some examples, and again, we have those ideas of those edge cases in mind. What would happen if we did these various things? So we have S of 0 up to the length of S specifies the trivial case of the whole string, because if you go up to and including the length, remember that the length goes over the edge, right? But we go up to but not including that, so it actually pulls out our whole string, and it actually works pretty well. And I think this is probably the reason why Mr. Rossum chose to start the indexing at 0, is because the length of the string then works quite nicely with this convention. So if you do the slice from 0 up to but not including 8, you get the whole string. So usually you don't do this slice, but you could. If the start index is equal to the stop index, then the substring will be empty. So if we say S of 2 up to but not including 2, what do we get? Well, nothing. So it's this, and so we get the empty string. If the stop index is equal to the start index plus 1, then we have the special case that basically we have just done the indexing operator. And let's see what we mean by this. So if you're going to do a slice from 0 up to but not including 1, which position is left? Well, that means S of 0 is what's left. So I could have just done the indexing operator S of 0 instead of S of 0 up to but not including 1. So you see that we get the same thing. So they're equivalent, and we're writing this out right here. S of the start index up to but not including the stop index is exactly equivalent to the S of the start index when the start index is just 1 greater. Some more examples. Again, we'll continue on using Michigan. Slicing beyond the length of the string adds nothing to the resulting string. Now, the curious thing about this is that when you do the indexing, if you try to index a position that doesn't actually exist in your string, you'll get an error, but in the slicing, that doesn't happen. And so if you try to take the slice, say, for example, from 0 to 100 of Michigan, obviously, this is much longer than the actual string. We simply just get out Michigan. So Python will simply just terminate at the upper bound in the string itself. If the start index is further right than the stop index, then the empty string is returned. So let's take a look at why this might be happening. So let's say we have S of 7, right? S of 7, that's the N, down to the 0. Do you see that we're going from the right to the left instead of from the left to the right? The convention in Python is when you're moving from the right to the left, that is going backwards, you simply get the empty string. So you want to always go from the left to the right to actually get something, because otherwise if you go backwards, it will not collect anything. Few more examples. Negative indices can be used just fine. So here we have S of -7 up to but not including -4. So we're going to slice out ICH. And the positive and negative indices can be mixed if you wish to do so. I don't necessarily recommend doing it, but there's nothing saying you can't. So here we're going to have S from -5 up to but not including +5. So that selects H and I. There are also implied indices. So again, this is Python attempting to be so helpful. If the start index is omitted, Python assumes that you want to begin at the beginning of the string. So notice here we have S of nothing up to 4. And so, well, what about that? Python assumes you want to start at the 0th index. So it will slice out for you 0 up to but not including 4. So you'll get Mich. If the stop index is omitted, Python will similarly assume that you wish to go to the end. So if we go S of 3 to the nothing, it will go from 3 to the end. If neither indices are specified, then the substring will be exactly the same as the whole string. So you've basically sliced the whole string, or you didn't really do anything. All right, well then, I hope that this was helpful to you in seeing how the indexing and slicing operators work in Python. They are quite useful for pulling out the substrings and working with the strings. We'll see that these are going to become quite important as we're working on the looping over the strings. So these are great skills to have, and hope that this has been nice and clear for you. We look forward to returning to strings the next time, where we'll talk about a few more of the Python built-ins that are available for you to work with. See you next time.